Good day to all of you. So, on our previous lectures, you already have a knowledge about basic electronics and then circuit diagrams. Now, in this fourth chapter, we will study all about basic prototyping. So, in this chapter, we will learn where to set up a work area and then all about breadboards, what Dupont or jumper cables are, and how to prototype a project. Okay, so our first term in this presentation is prototyping. So prototyping is not just used for hardware, it's also a term used in software. So prototypes are used to prove the specifications for a working concept or process rather than theoretical ones. So actually, this is an application of your theoretical concepts. For example, you created a circuit in a circuit, for example, Tinkercad or Fritzing, and then you're really going to create the actual project. So the ones that you have created, that's already a prototype. So prototype is a model to test a concept or process, and then prototyping is the process of creating and testing the prototype. So prototyping or the prototype, its main goal is to create or to have the main functionality of your project. It does not care about the statics or the project or how will the project look like. Its main goal is to have the main functionality, and of course, this is functionality, it should operate as expected. Okay? And then there's also for because it is a prototype, you will have more revisions for your main functionality to be more efficient and better in the operations. Okay, next is setting up a work area. So before you create a prototype, you need to look for a work area, specifically if your prototyping or your project is a very big project that needs space. So the first item we need to consider when deciding on a work area is static electricity. As you have learned in your science courses, that static electricity, an example of it is, for example, um, you came to a house and then rubbed your rubber shoes on a rug, and then you touched the doorknob, a metal doorknob, and then a little bit you felt an electricity, so that's already a static electricity. So have a table or bench large enough to hold your projects, and preferably one that you can store the projects on for extended periods of time. And then make sure to have plenty of light in your work area, especially you have electronic components that are very small in size. If you do not have this plenty of light in your work area, you will have a difficult time for electronic components that is too small, and in the long run you will have a problem with your eyesight. And then the final thing you will want to look for in your work area is plenty of storage, especially again if you have many electronic components, different kinds of electronic components. You must categorize and group them and then store them separately for each type and kind. And then some tips to avoid static electricity when working with the Arduino or other electronic components. Touch something metal to discharge any static electricity that has built prior to touching an electronic component. That's why if you can see a washing machine or a refrigerator with a wire, it's either you connect it to the ground or you connect it to a metal, because that's the way for the appliances to remove or discharge their static buildup, because it's very dangerous for example, a refrigerator or a washing machine would have a very it has a very big static buildup. You can be electrocuted because of that, and actually it can also cause death. And then avoid, if possible, having carpet in your work area or wearing rubber soled shoes. Okay, next is be careful of the material of your clothing. Wool sweaters or socks can cause static buildup, so opt for cotton instead, especially if you are there in your working area. And then avoid petting any furry pets while working because friction, static electricity can be built in friction. And then if your work area is dry, use a humidifier to add moisture to the air. So a humidifier is, I don't know if you're watching Korean novellas and then there's a scene in the hospital. For example, the main lead character is in the hospital confined and then there's this device that has a white smoke coming out to that device. Actually, that's already the humidifier. Okay, so after setting your work area, so we're having this component that is very useful and very important in prototyping. So using a solderless breadboard. It is a good idea to avoid connecting LEDs, resistors, and other electronic components directly to the Arduino because you can easily damage the headers on the Arduino and the circuit quickly turn into an unorganized mess. So that's why it's never a practice to directly connect the electronic components to the Arduino. So a solderless breadboard enables us to connect electronic components together without the need to solder. By the word itself, solderless, meaning you don't need to solder the electronic components to be connected. So you're going to use a solderless breadboard. And it is used in line with Arduino so that you can avoid connecting the electronic components directly to the Arduino. So this is an example of a solderless breadboard. You don't need to have a soldering iron to put the components. You just need to place it and connect it to the points or to the holes. Okay, we also have another type of breadboard. This is a longer one. And then they have their own ground and then for another input voltage and for two input voltages or voltage sources, power sources. And then this is the typical breadboard. Okay, they have this color coding. Red, okay, this red one meaning this line is for positive. So this is for also for positive and the blue one is for negative. Actually it doesn't matter if you connected it to the blue the positive or the red to the negative, but just to follow the standards. So what if your components, you have many components connected in here, so you'll not be confused where to put the power source and the ground if you follow the standard colors for positive and negative or the power source and the ground. Okay, next is we have the MB102 breadboard contains two positive and two negative power rails which makes it easy to connect the power and ground pins from the Arduino to the electronic components needed for the prototype. The positive rails are usually marked on the breadboard with a plus sign and the negative rail is marked with a negative sign. As I've said in the previous slide, positive sign is for red and then negative is for the blue and those types of breadboard. Okay, what is this illustration? This just means, for example, if you connected up the power source, for example, from the Arduino, if you connected it to one point, meaning all the other points will also be power sources. You just have to connect one point to the power source and all other points will be signals for the power source, and it is also applicable example for this one. You connected ground coming from the Arduino, meaning all the other points horizontal to the point that you have connected, these are all, the signals are all for the ground. So that's also the same with this one. So the power rails run horizontally across the breadboard where all of the connectors along the horizontal rail are usually connected together. So that's what I've been trying to say in the previous slide. So the pins in the middle of the board are connected together vertically. However, the connection does not cross the center of the breadboard. Okay, so this one, again, if you as I've said, if you connected one here, going from the source, power source from the Arduino, the other points here are all will be the signals for power source, and then again, for the negative or the ground, of course, if it's from the Arduino, also it applies just the same, that all the points here are the signals for ground. And it also illustrates that this is horizontally connected, while these points in the middle of the breadboard, these are all connected in vertical fashion. So if you connected, for example, the anode of the, for example, for the LED, meaning these are all belong, for example, to the LED. That's the notion for this breadboard. And as you can see, this middle, it does not have, it divides the two portions of the breadboard. So if you want to connect this one to the other one, to the other side, you need to connect another wire so that it will be continuous to the points. So for the vertical, you can never connect it in this way, just like with your power source and ground, because the connections are in vertical, and while this one are all in horizontal. Okay, so if you're going to open your breadboard, but I hope if you do have a breadboard, don't do this, because you can never return it back to its original. You can never, actually, you can never use once you open the breadboard. So avoid it. It's just for the illustration of the picture. As you can see, the connectors for the power source and the ground, they are connected horizontally. So that's why. Once you connected from one end here, it is already connected. All of them are connected until the end of the point, from going from right to left, for example. And then this is, you can see, this is why it is said that it is vertically connected, and there are in the middle, they are not connected. So this one is just the same, and this upper part. Always read the specifications. Okay, you have to remember this when you purchase components like a breadboard, to make sure you know if there is anything different about the one you are purchasing. It can save you hours of troubleshooting. Actually, I have an experience of a different breadboard. So let's go back to this illustration of the connection. Actually, I've used this another type of breadboard, which doesn't have a color scheme for power source and ground. And then when we use it, for example, I connected a power source and ground here. And then I connected the component to the other end, and then it's not working. So I thought the breadboard or the component is the one that has a defect. But when I asked a help of our electronics instructor, and then I just realized, or we just realized, that this breadboard is different, because there are breadboards that, just like this one, it is divided in the middle, and then there's no connection. There are also breadboards that exist that in the middle there is no connection. So that's why when I connected a power source to this point, and then when I connected the components to the other side, the power source and the ground will not flow, because it is divided in the middle. They are not connected. So the only way for you to connect, I realized the only way to connect it is how we're going to put a separate wire for the both of them, so that for example, the power source will continue to flow until the end of your of the point, and where your components are connected. So not all breadboards have this connection straight ahead until the end, because there are also breadboards that their power source and ground are cut in the middle. Then there are different power sources for this side, and then there is also a different power source for another side. But then if you want to use the power source from this end and ground, you need to connect again, as I've said, a separate two wires, to be exact, so that it will be connected. So that's another type of breadboard that I have encountered. Okay, next is when working with the Arduino, we can usually run power and ground directly from the Arduino to the power rails on the breadboard. However, there are times where we may need external power. As you can see, Arduino has their own signals for 5 volts, 3.3, and ground. So you can use their power sources and the ground coming from the Arduino. But of course, there are also shields that they have their own external power. It's because Arduino cannot simply supply the needed power that these Arduino shields are requiring. So this is an example where this component has its own power source. Okay, next is aside from the breadboard, we have the Dupont or jumper cables. So Dupont cables, also known as jumper wire, are used to wire components together when using a solderless breadboard. So these cables come in three types. We have the male to male, male to female, and female to female. Okay, so this configuration, unfortunately, we don't have the other side. So if it is male to male, it's not being looped, okay? It's really the standard to be called for wires. So this is male because it has a pointed pin. So male to male, meaning the other end is also pointed. And then if it is female, it will have a hole. Female to female, both of them has holes, and then meaning they can be connected to a pin. And then we have also the other configuration, which is male to female or vice versa. The other end is pointed for male, and then the other end has a hole. So again, male to male, both the Dupont cables are pointed, and then male to female, pointed, and then it has a hole, and then female to female, both of them has holes. Okay, let's go back with prototyping. So prototypes are used to prove the specifications for a working concept or process rather than theoretical ones, just like the definition in the first slide. So a prototype is a model to test a concept or process. So this is an example of a prototyping board. You have an Arduino Uno board, and then you have a breadboard, and then you will put any of the components that you will need for your prototyping. So, what are the steps in prototyping? So, first is have an idea of what to build. Typically, you have an idea of what to build. For example, you encountered a problem that can be solved using Arduino. You could use that as the basis for your project. And then break up the idea into the different building blocks. Then diagram the circuits that need to be prototyped. And then begin building the prototypes. So these are the steps for prototyping. So for building blocks of an electronic project, as you can remember, these are the input. These are the sensors, range finders, proximity sensors, and then the control circuit. We have the central processing unit or the microcontroller for the Arduino, and then we also have the output. For example, motor, LED, and then other devices classified as outputs. And then of course, input control circuit and output must have a power supply for it to work. Okay. And then after that, we need to create a diagram. We need to create a schematic diagram and a circuit diagram. You're just using Fritzing or Tinkercad for the design of your circuit diagram. And then start building your prototype with the physical electronic components needed with the Arduino and the breadboard and the Dupont wires. Okay, this is an example of a circuit diagram. where you have two LEDs, and then there's a push button, and then there is also a temperature sensor. This is a different temperature sensor. Temperature sensor comes in different types and sizes. And then we have the Arduino board, and it's connected to the breadboard. Okay, as you can see with the circuit diagram, it is the first prototype. The resistor that we're using for the button is called a pull-down resistor because one end is connected to the ground. Okay, let's see it again. So this one is the push button, and then we have this resistor, and it's connected to the, okay, black. So black is associated with ground. So this resistor, as already stated in the next slide, this is a pull down resistor because it is connected to the ground. Pull down resistors are resistors that are connected to the ground. Okay, a digital logic circuit can really have three states. We have high or one, on or yes, and then low. Low is zero, off, no for a logical description. And then we also have this floating. So what is this floating? So the floating state occurs when the pin is neither pulled high or low, but is instead left floating. It's either between 0 and 1 or high and low. So that's why it's floating. The state does not know is it really on or is it really off. So in this floating state, the microcontroller could unpredictably interpret this state as either high or low because floating state, you can never really identify is it really on or is it really off. So we really need to decide this floating state, what will it be? Will it be a high signal or a low signal? So to solve this issue, a pull-down resistor is used to pull the floating state low. So for a pull-down resistor, again, pull-down resistor, these are used to pull the floating state to low. So you're forcing the floating state to be off or low signal. And then another one, if the resistor was connected to the voltage supply rather than ground, it would be considered a pull-up resistor. So if pull-down resistor is connected to the ground to force the floating state to low, pull-up resistor is connected to the power source. So to make the floating state, to force the floating state to high or on. So a pull-up resistor works in the same manner as a pull-down resistor, but rather than pulling the floating state at low, a pull-up resistor pulls it high or make it on signal, or you force it to be on or in high signal. So this is the example of the prototype, of the actual prototype of the circuit diagram that we have. So these are the the jumper cables, and then based on the design, you really need to create a prototype. So this is an example. So for summary, so we have basics of prototyping, and then what steps should be taken when we are creating prototypes. Okay, do you have any questions? So if you do have any questions, feel free to comment, feel free to ask. And then if you do not have any questions, thank you very much for listening. So I hope you're going to tune in for the next videos. And then I hope that you learned from this lesson. So again, this is Blanca Flor P. Arada. So if you don't, so thank you again. Good day and stay safe.